Hi, my name is Gabriel, and today I'll be covering trigonometry graphs, the basic trig graphs, first-time tutoring. So first off, a quick throwback to the unit circle. Hopefully, when you look at this, you're not overwhelmed. This should be something that you recognize. This is just our unit circle, right? Going from 0 to 90 to 180 to 270 back to 360 degrees. Remember this counterclockwise rotation, and the idea is that this unit circle would be centered at the center of a coordinate plane, with each of the 4 points of the circle being a different, like, right, point 1 comma 0, 0 comma 1, negative 1 0, and 0 negative 1 on the graph. And the idea is that as you move along the border of the circle, you have a different point at each you have a different uh, set of coordinates for each different angle, right? So at 30 degrees, we have the x value √3/2 and the y value 1/2. So hopefully you understand these concepts well because they're going to be very important in graphing it. And remember, the sine function is the y value divided by the radius, cosine is the x value divided by the radius, and tangent is y/x. Now, because for the unit circle, radius is always 1, we just end up taking the y value for any of these points, and that becomes the sine function, right? So if we had sine at 30 degrees, we would just take 1/2, and that would be it, because the radius is 1. But it's really 1/2 over 1, which is 1. And tangent is x over y, y over x, which is pretty self-explanatory. So first off, let's look at sine. This animation right here is amazing because it shows, as we follow this point P around the edge of the circle, we can see the triangle formed, right? We can see the cosine value is greatest when P is on the maximum x values, and sine is the greatest whenever the point P is at the lowest or the highest point of the circle, right? At y equals 1 and y equals negative 1. So we're going to be going back to this animation right here to understand how the graphs work. So first, since we're looking at sine, we look at the y value, right? When the point comes back here at 0 degrees, we can see that sine's value is 0 because there is no y height. It moves up to the top at 90 degrees, sine is the greatest, or pi over 2. Uh, yeah, pi over 2. And then at pi, sine would be 0 again. 3 pi over 2, sine becomes negative 1 because it's the greatest or the least y value, and then it goes back to 0, right? So this is also important because as we look at point P, let's move on. Let's remember that point P represents what we're really looking at when we graph sine. We're looking at the degree. So we're plugging in degrees for sine, right? And we have to remember that because it moves in a circular motion, sine of 360 degrees is the same as sine of 3,600 degrees, right? Even though this angle is 10 times greater, they still come to the same point on the unit circle. It's just a different number of revolutions. So that causes the sine graph to look like this squiggle that repeats forever. And this sort of cyclical motion makes it very unique to graph. And because sine is pretty unique around the full circle, that means that it has a period of 360 degrees, or 2 pi, right? 2 pi radians. So that means that the period of sine is going to be 2 pi, is what you hear the most often. Also, when you're calculating the period off a graph, remember this formula, 2 pi over b. We'll be talking about this later. So next up, a couple keywords. You have amplitude, which is the distance from the middle of the graph to the peak of the graph. And this is also equal to the radius, right? Um, so if we're looking right here, if we're looking at 0 degrees, uh, the we take from the middle of the graph to the maximum point, the amplitude is 1, right? When the radius is 1. If we increase the radius of the circle to 2, all of the maximum y value for sine, right? We can see here that this is the maximum value, which is 1, that's 1, that's negative 1, that's negative 1. If we increase the radius of the circle to 2, sine could potentially equal 2 or negative 2. So the amplitude would increase. So basically, amplitude is kind of linked to radius, and amplitude just has to do with the maximum value, basically. And next we have phase shift. Phase shift is sort of, think of it as like a horizontal translation. This graph is not phase shifted at all because it's the parent graph, but phase shift is you want to remember to you just want to remember phase shift means a horizontal translation. So let's hop into a practice for graphing because this will be the best way to understand really what's going on here. So we have this function y is equal to 3 times the sine of 2x minus 2. So first, let's take a look at our parent graph, right? We start at 0, 0. Pi over 2, which is 90 degrees, has a point of 1, which if you think back to your unit circle, you should know sine of pi over 2 is 1. Sine of pi should be 0, sine of 3 pi over 2 should be negative 1, and sine of 2 pi should be back to 0, right? This is a full sine revolution in the unit circle. So just plugging in the radian value into the sine function, we should be able to visualize this pretty well. So now let's start working on translations, or sorry, alterations that have been done to the graph so that we can see what the end result looks like. And we're going to be working with these same 5 points because this is the easiest way for us to visualize the sine graph. So first, we'll notice that the graph changed, and this is because we're going to start. So here's the standard form of the sine function. Y is equal to the amplitude times sine of bx plus c plus d, where b is the coefficient of x, c is some constant inside of sine, and d is like a vertical translation. So amplitude is just whatever sine is multiplied by. The amplitude is 3, which you could also take it as being the radius is 3. So that means that whatever value we have, the y value on the sine function is multiplied by 3 from the parent graph. So that means that the maximum potential value at pi over 2, instead of being 1, it's 3 times sine of pi over 2. So it just becomes 3. So maximum amplitude is 3, right? That's a fairly straightforward step. Moving on to the period. So remember I said the period, to find the period, it's 2 pi, which is the base period, over the coefficient of x. In this case, our coefficient of x is 2. So we just do 2 pi divided by 2 to get pi as our period, right? And we know to divide by 2 because it's right here, just the coefficient of x, right? So 2 pi over 2 equals pi. So now we know the period is pi. Now before, looking back at our parent graph, before, the period was 2 pi, right? Because when we plug in 2 pi, it goes back to 0. The 2 pi is like 360 degrees. It's a full circle. But now, because we have 2x inside of here, for any x value that we plug in, it's going to be 2 times greater, meaning that if we plugged in 180 degrees for x, we would already reach 360 degrees. So the graph gets scrunched kind of like this because it goes much faster. So now the period, now you'll see each of the x coordinates got divided by 2 essentially. So it goes from 0 to pi over 4 to pi over 2 to 3 pi over 4 and then to pi, finishing a full cycle at pi. So the graph kind of, everything got scrunched a bit because the period is pi now. So in our 5 points, instead of going from 0 to 2 pi, we go to 0 to pi. Finally, we have the phase shift. And I say finally because there's no d value, you'll notice, because there's no d anywhere to be found in our function. So for phase shift, because there is a coefficient for x, in order to find the actual value of the phase shift, you have to factor out x's coefficient, right? So you could factor it out, or you could just do c over b. Now c is the kind of the constant that's over here, and b is just the coefficient. So we're just doing c, which is 2, over b, which also happens to be 2, which we get 1. So our phase shift is 1. And it's counterintuitive, remember, on all other graphs as well. Whatever horizontal translation we have, we do the opposite of the sign. So it is minus 2, or sorry, it is, yeah, it's a minus, so we're actually moving it to the right, where plusing kind of is counterintuitive, right? So we get 1, so we just move everything over 1 to the side. Sadly, if you're using a graphing calculator like Desmos, it won't show your points anymore, but this point right here, it's just 0 plus 1, right? And then the top point should be pi over 4 plus 1. The middle point is just pi over 2 plus 1, and this last point right here over here would be pi plus 1, which makes sense, right? 3.14 becomes 4.14. So perfect, that is sine. And once again, translation or vertical translation is 0 because there is no d value. Next, moving to cosine. Cosine, you'll notice cosine at 0 degrees, its maximum. So cosine starts at its maximum, moves to its neutral point, moves to its minimum, back to neutral, back to maximum. And because of this, our first point is maximum, right? So it looks just like the sine graph, right? You'll notice it's exactly like the sine graph, except it starts at its maximum instead of starting at a neutral point. So let's just jump into another one. We're using the same strategy. For all of these trig graphs, you use the same strategy, same amplitude, and all of the same stuff, right? So if you guys want to pause it right now actually to work on your own before looking at the solution, you can go ahead and do that. Or if you want to follow along with me as I solve it, go for that as well. So give you a second to pause it. And let's work through figuring out how to graph it. So, right, let's look at our parent graph again, right? Just for reference, one more time. It starts at the maximum, so we'll have a graph that ends up looking like some variation of this. First, you take the amplitude, right? We take our standard form function. Amplitude is just whatever the cosine is multiplied by, which is 2. So we just increase all the y values of every point on the cosine by 2. That just means that our maximum points and our minimum points, instead of being 1 and -1, become 2. Next up, the period, we're doing 2 pi, because remember, cosine's period on the unit circle is still 2 pi, so we're doing 2 pi over b, and our b value is 4 right here. So we're just doing 2 pi over 4, which becomes pi over 2. So now our period is pi over 2, meaning that the graph is super, like, it's really tight. It goes from 0 to pi over 2. And that means each point, every x point on the graph, is basically being divided by 4. So this point right here used to be pi over 2, but now we divide by 4 and it becomes pi over 8. So that's really what the period does. It just scrunches everything down. So we go from 0 to pi over 2, and we do our 5 points. And at equal intervals of pi over 8, we'll have our new points. So 0 to pi over 8, to 2 pi over 8, or pi over 4, to 3 pi over 8, and to pi over 2. And finally, we have our last value, which is just plus d. We have a vertical translation of 1, so all of the y values get bumped up by 1. We can see now that the maximum point is 0, 3, or pi over 2 and 3, and the bottom point is pi over 4, -1. So really just move the whole graph up by 1 unit, nothing you haven't seen before. Alright, finally is tangent, and tangent's a little bit tricky. So if you remember, tangent is y over x. And basically, tangent's a bit unique because it's it what ends up happening with tangent is that in a full revolution, we get two cycles of tangent, I suppose, right? And this is because in the first quadrant, because tangent is a fraction of y and x, in the first quadrant, y and x are always positive, so tangent's always positive. In the second quadrant, y is positive, but x is negative, so tangent is always negative here. In the third quadrant, y and x are both negative, so tangent's always positive. And in the fourth quadrant, y and x are, y is always negative, but x is always positive, so tangent is negative. So tangent goes positive to negative to positive to negative, meaning that really it has two copies of the tangent thing in one, of the tangent graph in one full rotation in 360 degrees. So what this means, basically, is that the tangent graph has a period of only pi instead of 2 pi. So we use the exact same strategy that we've been using on the other graphs, except our period is now just pi, right? And this is also something that you may have already noticed just by looking at the unit circle or by doing just basic unit circle problems. So looking at this graph right here, once again we'll have this whole 5-point system where the lowest point is actually this asymptote at negative pi over 4, and the highest point is another asymptote at, lowest point is at this asymptote at x is equal to negative pi over 2, and the highest point is an asymptote at x equals pi over 2. And this is because when tangent is pi over 2, what we end up having is y over x, right? The sine value at pi over 2 ends up being 1. And the cosine value at pi over 2 is 0. So we're doing 1 over 0, which is impossible. It's basically really, really big. But if we look at just below pi over 2, right, the sine value is very close to 1 and the cosine value is very close to 0, so we get almost infinity. So that's why the graph explodes to infinity and negative infinity as it approaches pi over 2 and negative pi over 2. So that's why we get this repeating kind of like asymptote-like graph. And the other point is just right here in the middle, which is 0, 0, and pi over 4 comma 1, negative pi over 4 comma negative 1. And it's that period of pi, right? So if we start at pi over 2, we go to, or negative pi over 2, we go to pi over 2 because that is a period of pi. So that's basically the gist here. So let's practice graphing 2 times the tangent of x over 2 minus pi. First off, the amplitude, we're multiplying everything by 2, so all of our y values are increased by 2 pretty much, right? Just like the other ones. Amplitude is 2, very easy to take just by looking at the function. Next is the period. We know how to do 2 pi over b from the other graphs, except this time tangent's period is only pi, so we do pi over b. In this case, b is 1/2, right, because we're dividing x by 2. So we're doing pi over 1/2 becomes 2 pi. So now our period for the tangent graph is 2 pi. We have this line at negative pi and this line at positive pi, these asymptotes, right? So we can see from before we had pi over 4 and negative pi over 4 comma 2 as our, I guess, reference points, and now they become negative pi over 2 comma negative 2 and pi over 2 comma 2 because the period is now 2 pi, right? We're going from negative pi to pi. And finally, we have the phase shift. Phase shift, we just divide c by b to get our value, and c is just pi, so pi over 1/2 becomes 2 pi. That means that we have a phase shift. Because we're subtracting pi, we're moving it, we do the opposite of it, so it's a minus, so it's actually a plus. That means that we're moving it 2 pi over to the right. That means that our main point, our center point, is no longer 0, 0, right? It is now 2 pi comma 0, and then we just add 2 pi to each other point, so pi over 2 becomes 5 pi over 2, and negative pi over 2 becomes 3 pi over 2. And that is it for the tangent graph as well. So hopefully these tactics for graphing the graphs help out, and I will see you guys in the next video. Thank you for watching.